Okay. So objects thrown at an angle. This has the basic principles as a projectile thrown horizontally, but you first need to break the initial velocity down into the x and y components because it's thrown at an angle. So we cannot assume that the vertical or initial velocity is 0. Did the door just knock?
I think somebody knocked the door.
This is a big thing that we can't assume. So star, highlight, circle that. Okay. The initial vertical velocity will be the y component of the initial velocity, so we can't make the assumption that it's 0. The horizontal velocity is the x component of the initial velocity thrown. So if we were to draw in the vector arrows of our cannonball, so here is our theta, is the angle that it was projected at. Now normally, in most of our questions, so say it tells you 30 degrees, that's 30 degrees relative to like the ground or wherever it was shot out at. So if the cannonball is shooting it out, it's 30 degrees is the angle at which it was projected upwards. So it's not 30 degrees according to like our bearing navigator's method, it's just 30 degrees in reference to where it was shot from. Okay? I'll give you more examples. Okay, anyways, so our overall vector is going this way. So our overall net V is going that way. But I need to break it down. So I have a Vy that's going up, and I have my Vx, my horizontal vector. Okay? Continues, I still have this, going up, down. So let's put these in now. So here again, I will have a Vy. It is smaller though than the first one because it's starting to slow down as it reaches its highest point. Vy at the top point, what do you think it's going to be? 0. There's no vertical vector at Vy. Our Vx's still going, Vx, and I still have my Vx. Also note this spot here is at max height. So just like when we had those questions where we tossed a ball up, at the maximum height, according to this, the velocity is 0. Okay, the next one. Okay. Next one, what color did I use? This one. My Vy is now going down. I still have my Vx. As it carries on, I then have my Vy going down and my Vx. Now there's a couple assumptions we can make about these. So just as when we were tossing our ball up and our ball down, we could make assumptions about what's the same across. So let's call this one B, and let's call it this spot where it's initially shot out as A. So I can make the assumption that because A and B are at same height, that my Vy A is equal to negative Vy B. So that this vector is the equivalent to the negative of this vector. Okay? Moving on. Okay, so an example. An object is thrown into the air with a velocity of 20 meters per second at an angle of 30 degrees from with the horizontal. So that's kind of 30 degrees from the ground, okay? Or for wherever it was shot from. What is the total time the object is in the air, and how far does the object travel horizontally? So, we need to break this all down into horizontal and vertical ideas. So first I'm going to draw a diagram. Drawing a diagram. Okay. So here's my ball or whatever I'm shooting up, and it's shot up at an angle of 30 degrees. And it has a parabolic trajectory. The V at this spot is 20 meters per second. So I need to break this down into its x and y components. So I'm going to redraw this vector. This is my overall V is equal to 20 meters per second. My Vx and my Vy. And I know this is 30 degrees. So now I need to figure out the individual Vx and Vy of this. Well, how do I do that? Use trigonometry. So to figure out my Vx is equal to cos theta equals adjacent over hypotenuse. So I can say this is cos 30 degrees is equal to Vx divided by 20 meters per second. You cross multiply, so Vx is equal to cos 30 degrees multiplied by 20 meters per second. So Vx is equal to 17.3205, etc. meters per second. Then you need to find your Vy, which will be sine theta is equal to opposite over hypotenuse. So sine of 30 degrees is equal to Vy divided by 20 meters per second. Again, cross multiply and solve for Vy will equal 10.0 meters per second. Okay, so we've solved for our horizontal and vertical vectors. Do you still need to see? Good. So now let's break all of our information into our horizontal information and vertical information.
What is your Vy?
Oh, sorry, 10. So this Vx is like, this is my horizontal. That's my horizontal speed, and this is my vertical speed, or velocity if it has direction. So now I can take those and put those into my category. So VI for vertical is 10 meters per second. I know my A is negative 9.81 meters per second squared because it's going up and down. Pardon? If I was just dropping it, then I could say acceleration due to gravity was positive. Okay, I can also set my VF is equal to negative 10 meters per second, assuming that I'm taking my VF directly across from where VI started. Okay, and I can, so now I'm going to put everything I know for my horizontal. V is equal to 17.320 meters per second. My D is what I'm trying to figure out. That was the first, or one of the questions in here. How far does the object travel horizontally? Okay, so my T, what am I missing to figure this out, my T? Well, what can I assume about T across the board here? That it's the same on both sides, okay? So T is the same on both sides. So I can solve for T using my vertical information. I'm just going to erase this to give me a bit of space. So here, A is equal to VF minus VI over T. If I rearrange it, T is equal to VF minus VI over A. So T is equal to negative 10 meters per second minus 10 meters per second divided by negative 9.81 meters per second squared. So T is equal to 2.0387, etc. seconds. So now I can use that time and put it into my horizontal. Oh, and this is one of my answers. So A, my answer to A is T is equal to 2.04 seconds. Now I can solve for D. So D is equal to V times T. D is equal to 17.3205, etc., meters per second, times by 2.0387 seconds. D is equal to 35.319 meters. Sig digs, D is equal to, so this is for answer B, D is 35.3 meters. It's a lot of steps to the question.
How do you know when VI is equal to velocity or when it's equal to 0?
If you're 0 is only when it's at max height. So
Like, how do you know when you're dealing with when it's thrown at an angle and when it's not?
well, it will tell you because it will say at an angle of 30 degrees. Is that your question? I don't know if I know what your question is. Do you want to rephrase?
No.
'Cause okay. All right, so I want you to try page 112. numbers 6 and 8. Page 112, numbers 6 and 8.